So good evening, good evening. Tonight, the plan is it's a free for all on that sample final exam. You can get excited about that, getting questions answered. And that just needs to be turned in tonight by midnight. I will give the bonus like I did before. Your chapter 11 project is due tomorrow. I was caught up, but I think a couple people turn theirs in today. So I was caught up on grading on that. All the chapter 11 reviews have been graded. FSL I updated last week, so I'll update again, obviously at the end of this week. So get in there, make sure you're getting those chapter 11s done. Those are due this week. And get registered for any classes that you want to take. So that being said, I'm all yours.
I have questions on problem 18 and 19 of the sample review.
And you're lucky. I all took a Tylenol like an hour ago. It's just had such a splitting headache. I think it's the pressure change outside. Anybody else? I'm like, literally, I'm like, somebody pat my head. Like,
excruciating. I mean, it's even to the point where it hurt. My neck even hurts. To
yes. And I didn't sleep well last night either, so I don't know if I'm
Me neither.
top of it. Maybe, and they say like full moon, sometimes you don't sleep well. And last night, I was wide awake last night. It was
I had a migraine all day yesterday.
I think tonight's supposed to be one of those full moons that are pink. Is that what, anybody else hear that too?
Yeah, it's called the pink super moon.
Yeah. Okay. But I'm feeling better now. I'm rallying for you guys because I love you all so much.
I have a question on 5 as well.
Okay, so let's start with 5. How about we start with 5? Ah, and I've already answered it.
Apparently.
Let me find, let me see if I have one that I haven't. I don't think I have one that I. Oh, that stinks. I don't think I have another one I haven't written on, but that's okay. So question number 5.
Mhm.
Well, there you go. But what was your question so we can talk about it some more?
I was just confused about how to determine whether or not the sample is considered relative, be considered to be representative. Yeah, I was just confused about whether or not it's representative of the population of the United States. And it says no, they were biased. And
Anybody want to chime
why
in?
would that be?
Yeah, why are they biased?
Oh, because it's a online poll, so they're only getting people that make their way there to take it. Okay.
Right, exactly.
I was more worried about the numbers. That's why I was getting confused.
Yeah, because I mean, there's a lot of responses, right? Over 1 million, 1.3 million responses.
That's a poop ton.
What?
I said that was a poop ton.
Okay, so let's go to your questions on, what was it, 18 and 19?
Or was it 19 and 20?
19,
Let me.
20.
No, it was 18, 19. Yeah.
Okay, good.
18.
Just a minute, I gotta respond to. Everybody read through this 18. I'm gotta respond to Joanne. She can't get in.
Jasmine, how many other bathrooms are in this house?
Oh, there's Joanne. Okay, so number 18 says Nielsen Media Research, which estimates the mean number of The mean number of hours that high school students spend watching YouTube on a weekday. A margin of error of 0.25 is desired. Past studies indicate that the standard deviation is about 0.75 hours. Estimate the minimum sample size required to estimate the population mean with a stated accuracy and 90% confidence. So our first question from the other night, what should we be asking ourselves? Did anybody write it down? I'm getting really sad thinking about this. What's the first question we should ask ourselves?
Is the population or proportion? Is that one of them?
It's proportion or means.
That's what I meant.
Is it qualitative or quantitative data?
Yeah, that's.
Anybody want to chime in?
A one sample or two sample?
That's the next thing, but we got to know. I didn't hear anybody say, is it means or is it proportions?
Oh, this is a mean, because it's asking estimate the mean.
Okay, so means. And Jesse is correct. Is it one sample or two samples?
One.
I'd say one sample. Okay, and then what was the third question?
Are we doing a confidence interval, hypothesis test, or a sample size?
Yep, thank you, Ashley. So what is it we're doing? What are they asking us for?
We're estimating the sample size.
Okay, so it says estimate the minimum sample size required. Okay, so this is what you'll want to ask yourselves every single time. It really does help. Even though you might be flustered. I know somebody on this call that didn't think they knew how to do these, but everything they sent me was perfect because they were walking through all of the questions. So let's see here. So what page would we be looking on for this? For means, one sample, and sample size? What yellow sheet?
$266.
266, okay. So there's,
Two,
I didn't hear you, Jesse, what was it?
the 9.2.
Yep, because we're talking about means. Yep, so there's only one choice because it's a 9.2. Talking about means, so we could even write that up here, 9.2. And then they wanted us to estimate that sample size. So we're gonna write down the formula first. It's N equals S, and then our critical value, right? And our error squared. So I'm going to fill in what we know. Our standard deviation is
0.75.
okay. And we're going to go, we'll go to StatCrunch here in a minute and do the critical value. So let's leave space for that. So the critical value though, let's just write over here, critical value. It's a 90% confidence. So the confidence level is 90%. Oops, that's supposed to be a percentage sign there. Okay. So we'll go back and do that. And then our error that they decided was a margin of error of 0.25. And because it's means, we don't have, it's not a percentage. We're not moving the decimal. It's literally just 0.25 because those are the units, hours. Right? So everybody should go with me. We're going to go to StatCrunch. And we're gonna go to calculators. And under calculators, we're looking for the normal calculator. And it's always a between when we're doing the critical value, right? Because we want to find those outside values. And so because it's a critical value, we don't have a mean and standard deviation other than 0 and 1. And then we're just going to put our confidence level right here. So 0.90 and hit enter. And there it is. 1 point. So the Z alpha divided by 2 is equal to plus or minus 1.645. So all we put into our formula is just 1.645. Not positive. I mean, we're going to leave it positive. So that's how you find your confidence or your critical value each time. So let's go back to this. So go ahead and keep working. I'm going to grab my, I don't think I have my calculator on this one. I think I have this one jotted down somewhere. I do. So this probably came out something like 24.35, right? But what's important for us to remember for sample size?
So you have to round up to the next integer.
We always have to round up. So it should be n equals 25. Brendan, are you good with that one? Okay, awesome. So let's go through and answer. I'll let you all answer the same 3 questions while I go grab my calculator. I was working on stuff out in the other room today. So I'll let you all talk through the 3 questions that we asked ourselves. Okay. I didn't hear anybody talking or sharing. What's our,
Oh, I have for the first one, it's a mean because it talks about the mean weight of all bags.
okay. Okay, so it's means. And second question is,
I believe it's a 1 sample, and the sample being just the bags.
okay, and then what do
It's
they
a-
want us to do?
They're looking for a confidence interval because it says construct a confidence interval.
Okay, awesome. So make sure that you read through the problems thoroughly, because on the last one, it did want to construct a confidence interval, but they wanted us to find the sample size along the way to do that, right? This one is just literally saying construct the confidence interval. So we're going to write CI. So we're going to use these 3 pieces of information, like we're playing CSI, right? Or Clue, and it's going to tell us exactly where to go in our yellow sheets. So can somebody tell me, where do we go in our yellow sheets from here?
It's the same page 266, but it is a 9.2. It says confidence interval for a single population mean.
Okay, so it's this right here. So I asked you to give me the formula, substitution, and answer. So the formula we're going to write down is the X bar plus or minus the critical value. This time we need a T critical value when we go to calculators. And then we need the, Now, because we have data and we're gonna put it into StatCrunch, you can just write down this formula here. So it's either this one or this one. But because we're gonna use StatCrunch, StatCrunch is just it's gonna already calculate the standard error for us. So we can just write standard error of the X bar here. Okay. So substitution. Okay, and then result, we can put down here. Okay, now let's go to StatCrunch and we're going to enter in our data. There's 4 pieces of data, so everybody can use some practice with that. Well, didn't mean to do that. No. All my boxes to checker in different places. So we're going to put in 20.2, 19.9, 20.5, and 19.8. 4 randomly chosen bags of horse carrots. Okay, so before I do that, I just want to confirm the critical values. So let's do the critical values. So calculators in T. And it's a between because it's a critical value. And so we need to know the degrees of freedom and the confidence level. So can somebody tell me what is the degrees of freedom and our confidence level?
Three.
Okay. Awesome. And confidence level? I didn't hear that. My Zoom was like being weird.
95%.
Okay, awesome. 95%. Thank you. So degrees of freedom, we're gonna put 3. And then here on the right-hand side, we're gonna put 0.95 and hit compute. And so our critical value is a T critical value, right? 3.18. So in our substitution, we can put that 3.18. And then the X bar and the standard error, that's all going to come out of StatCrunch here. Make sure that's good. Okay, so we have our data. So now we're going to go to stat and we are going to go to T-stats. Oops, stat and T-stats. We have one sample with data. And our data is bar 1. And the only thing that we have to go down is change this to a confidence interval. And it's already set up for 95%. So we can hit compute. So for substitution purposes, there is the sample mean 20.1 plus or minus. Then we already have the critical T value 3.18 that we came up with. And then our standard error is the other piece, and that's 0.158 for substitution purposes. And then the result is our lower limit, 19. I'm going to round that to 0.6 because it's 5968. And then our upper limit is 20.6. Pretty tight. But that's because we're pretty confident. Well, 95%. Now, if it's a 99% confidence, it'd be right, and higher confidence, it'd be wider. Okay, did everybody get that? Okay. So, yeah, the formula, you have the substitution and the result. You should be using StatCrunch. You can use TI-84 by all means, but StatCrunch is very nice and simple. Okay, I'll let you all pick another one that you want to work on, but if this is, I'm happy to assist, but we won't be able to get them all in tonight, so.
Can we look at that one again real quick and just go over how we got the which formula to use?
On this one, the 19?
Yeah,
Mhm.
so I'm looking at the white sheets.
The white sheets, the yellow sheets?
No, the guide, the chapter 11 guide,
Mm-hmm.
that's what you use to determine what yellow sheet you're gonna look at, right?
Well, to be honest, I just asked myself these three questions. And when we were, I'm bragging about Jesse here, and so because I'm bragging, I think I can do it on Zoom. He was saying that he didn't know how to do these last night, but we were texting back and forth, and he very much was able to answer all the questions himself that he was asking me. So I think it's just building up some confidence here. So if you can answer those three questions, Jesse, is it qualitative or quantitative? Are we talking about means or proportions? Is it one sample or two sample? And then what do they want us to do? What do we want to end up with? Then, then I just get out my gold sheets, and it really starts with chapter 9. So these are all my confidence intervals up here. They wanted a confidence interval. And you can even write on your gold sheet, chapter 9 is one sample. So you know that these are all the one sample. And actually, to me, a good thing for your note sheet for the exam would be exactly, you know, I know that you mentioned, and to be honest, I think this would be way too much for me to take in. And I think you mentioned that in the text too, that we were texting back and forth. These sheets were kind of confusing. So I would probably just have a guide where it says, is it quantitative, qualitative? You know, means, proportions. I would probably kind of go something like this, because this is the way my brain thinks. Now, my brain is definitely not how you all think. So you have to kind of build something that works for you. And
Well, I
then,
kind of like, I had that on my paper. Like you kind of showed us how to do that in the chapter 11 review.
yep.
of the
So
plan.
if you'd rather have a visual, like on the visual, you could just write the page number right there. Or you could write on your gold sheet, your yellow sheet, this is one sample. So you know at the top, yeah, this is all my one sample stuff. Because I know when you're not I know everything by chapter 9, 10, 11, because I talk about this, right? 2 or 3 classes every semester. So this is like the back of my hand. But for you all, you're just thinking one sample, two sample, yada, yada, yada. So I would maybe write at the top of chapter 9, one sample. So you know everything on this page is all one sample. 10.2, again, one sample, because this is hypothesis testing. And you can even write at the top, even though it says it right here, you can just write hypothesis testing, one sample. And then obviously it says proportions, so that's how you know that would be proportions. Again, this next one says 10.3, hypothesis. You could write the top one sample. Then when you get to chapter 11, you could write two sample stuff. And these are the confidence intervals for the two samples. So I pretty much rely myself everything on this gold packet and answering those 3 questions that we just answered. And so I don't know that I feel bad that I can't give you, I feel bad I can't give you one way to do it, but I think that's where you kind of have to sit back and ask yourself, am I a visual learner? Then drawing a picture of where things are and labeling them somehow might be your best bet. If you're just simply directions, then you might want to use, you know, something like these pages. This gets a little overwhelming for me personally. I fill it out because it's provided in the course pack, and hopefully it was to some use to somebody. But again, I know myself, I like a picture. That's just how I arrange things. And I like to keep it simple. And I found over the years that these are the 3 questions that I ask myself. And so I feel like that could help you all. If you can answer these 3 questions, it should help you choose which gold sheet you're going to for everything else. Because to me, there's no sense rewriting all of the CLT requirements because they're on every page that you need, right? Whatever page you're on, they're right there.
All right.
And by all means, ask it another way. You know, if there's something else right now, you're like, but I'm still not getting how to get here. I'm not offended.
Can we by chance look at page 680, or did you guys already go over that?
Um, Page 680, number 6 is on page 671.
No, it's number 23.
Oh, I thought you said 6.
I'm sorry. Yeah, it's page 680, number 23. I
Six,
didn't know that's been all gone over already.
right here?
Yes.
Sure.
I'm trying to figure out the steps, just like which way to go. So I kind of just sometimes hearing again would be helpful.
Oh, that's Joanne. Sorry, I just couldn't tell who the voice was. Okay, so what's the first question we're gonna ask? I'm gonna keep asking tonight. And you guys are gonna be so tired of thinking about it. But you're gonna know exactly what questions to ask on the final. So what's the first question we're asking ourselves when we read through it?
Proportion or mean?
Yep, so are we talking about proportions or means?
It'll be proportion because it says percentage.
There you go. That gives it away. That's what we're looking for. So proportions. And you could write percents. The reason I write proportions down is because that's the word I'm looking for in the gold sheet, right? That's what it's gonna be when I go to look. So I answered that. And then how many samples does it appear we're talking about? If you haven't read through it, take a minute and read through it.
Just to clarify, so if it's a percentage or proportion, then we know that's what it is then. If there's no other options. Okay,
Good question. Yep. If they're saying the percentage of blah, 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 there you go. If you see a percentage symbol because it says the confidence level, now that's something else, right? But other than that, if they're talking about percents in the problem and you don't see units anywhere, then that's what they're doing, is talking about proportions. Mhm. Good question. So does it appear that we're talking about one sample or two?
It's gonna be one sample.
Okay. And why do you think it's one sample?
It says it was given to a simple random. That'd be just one sample. And then later on, it says we're testing whether that sample has changed.
Okay. So historically means that 55% is our H0, right? Our mean zero. I should say P0. Okay. And so what do they want us to do? I think maybe Ashley addressed it, but. And don't look at my,
We're doing a hypothesis test.
okay, what clue do you have besides the fact that I have 1 through 6 written on my paper?
It says to test the claim that proportion has changed.
Okay. So notice that it's going to say something about test the claim. So that tells us it's a hypothesis test. Is everybody in agreement with those 3 statements? So for finding which yellow sheet, I would go to, this is how I would look. I would search. I would search for hypothesis test are the big 1-pagers, right? And I'm looking for a hypothesis test that says one sample and proportion. Well, I happen to have mine open to page 267. And it says regarding hypothesis regarding a single population proportion. So everything I need is going to be on this paper. I should not need anything else. So I'm going to have my hypothesis statement. And make sure that you've got your labeled 1 through 6 so that I can find everything clearly. And do they think that it's less than the historical or not equal to or greater than?
Not equal to?
And what words did we find for that, Jesse?
Just that it has changed. It doesn't say if it is like which direction has changed.
Okay, excellent. So has changed means it's this, right? Okay. And we think it's equal to the historical value, which was 55%. And they say they don't think it's equal to 55%. And what level are we testing at?
0.4.
Okay, 0.04 level. And disregard my Z0. We're gonna go to StatCrunch.
I was like, how do you have that already?
Because I was making out answer key for myself, looking at from my old answer key. There's some new, this is a new problem from the sample. On the sample final, that's why. Okay. I just work on this stuff in my sleep, you know?
Me too.
Okay. So we are going to stat and proportions because it says proportions. We said it's one sample. And oops, we have summary data. We do not have a data set. Oh, and this is one of those that we were not given the number of successes X, right? They said our sample was N equals 1011. And our P hat is 0.6. I'm gonna go back and show my paper for a minute. So when you were not given X, remember that to find X, it's N times P hat. And so that's 1011 times 0.6 equals 606.6. But remember, StatCrunch only takes integer values, so you have to decide is it going to be 606 or 607. So 606, I'm just testing it out. On this one, I kind of always test it out. 606 divided by 1011 gives me 59.9, and 607 divided by 1011 gives me 60. And that's the closest to my 60%. So I would probably use 607. Now, if you use 606, it's not the end of the world. I try to be as accurate as I can. So I'm going to use X at 607. So this is my number of successes, right? X is my number of successes. N is my number of trials. Okay. So 607 tab 1011. This time it is a hypothesis test, and we have to put in what our P0 is 0.55, and it's a not equal to. So we can hit compute. I'll wait just a minute to hit compute. Oh. And that's where I got my Z zeros. Ever see that my Z statistic is 3.22? That's my fancy Z score. So we are above the mean by 3.22 standard deviations. That is a lot. Okay. So my p-value means it's going to be very small. They go in the opposite direction, right? Okay. So number 4 is we're going to draw a picture. Wow, I have to show you because I did a really good job on this. I'm ending the semester with a bang. So we have a not equal to, so that means I'm shading it just like it is shown on the yellow sheet. So on the yellow sheet, right? It goes just like this. If it's a left-tailed, you're gonna go straight down. There's a left-tailed picture. If it's not equal to, straight down. There's a not equal to picture. If it's greater than and right-tailed, straight down, and there's the right-tailed picture. The only way to reject is if the p-value is less than alpha. Be super careful. There's people on the chapter 11 review worksheet that I think you just kind of aren't really looking at the numbers and you're like, oh, do not reject. Clearly it was less than. So just go really slow. And I'm saying clearly because I'm fairly confident you all know your inequalities. I think it's just sometimes we go too fast. So my p-value was 0.0013. My alpha that I was comparing was up here, 0.04. And so yes, p-value is less than alpha, so reject H0. In your statement 6, number 6, I have been very gracious in the chapter 10 and 11 worksheets, but you need to be writing, there is sufficient evidence. Some of you are writing, we do reject, and you're writing it in step 6. No, that rejects should only, those words should only be in step 5. Step 6 should just be referring to your H1. So there is sufficient evidence to support that. To support the claim that percentage of US people who want stricter gun control laws is different than 55%. Now, we don't know what it is, we just know it's different. Did that help on that one? That was Joanne?
I have a question, like, why can't we just say that the 60% is already different than the 55?
We don't know if it's statistically different though.
What is that?
We don't know if 60% is statistically significant.
Oh,
It's
just
different.
significance level is what we're,
Yeah.
because I just look at it, I'm like, yeah, obviously 60% is different than 55.
Okay. I like this. So so if you're wondering, if you're like, well, wait, how do we know? Think about what a p-value is. A p-value is if our true percentage is 55%, right? Then I should be able to draw a curve and go back to chapter 3 and say 0.55. And look at my error, my standard error for my standard deviation. So that would be the square root of 0.55 times 1 minus that, so 0.45, divided by my sample size of 1011. Oh geez. So, okay, so 0.55 times 0.45 divided by 1011. So that is equal to 0.016, we'll say. So we'll pretend these are the same. So 68% of my data should fall within 1 standard deviation, right, Jesse?
Mhm.
Okay, so that would be 0.55 plus 0.016, so 0.566, and subtract it would be 0.534. And then 95% of my data should fall here. Right, and we said anything outside of the 2 standard deviations is going to be unusual, right? And so if I take 0.566 and add 0.016, then my 2 standard deviations would be 0.582 and 0.518. So we said, so anything more than 58.2% of people that think we need stricter gun laws is considered unusual. And so you could just do it like this and go, yeah, 60% falls there. So we know it's unusual. That's essentially what we're doing, but excuse me, doing it this kind of old fashioned way that we did in chapter 3. I like to be able to look at you guys. Doing it the old fashioned way, we didn't really hit the exact 60% mark, right? And using our 2 standard deviation rule is really just using a 90% confidence. So changing the confidence level changes the curve a little bit, right? And then the p-value is getting a very specific likelihood. Here I was like, oh, yep, it's in the range. It's enough for me to say, yep, it's considered an outlier. Do you see where I'm getting at, Jesse?
Yes.
Okay, so does that answer your question?
Yeah.
Oh, good. Okay. So p-value is just a fancier way to do this whole empirical curve that we did in chapter 3 and be very exact about what our probability of this weird outcome is. But it's not really weird because we agreed it is unusual, and so I don't think this is actually true anymore. What's the next one y'all would like to look at?
Could you go over 1E?
What's the question on 1E?
To compute the mean, standard deviation, and variance from the frequency distribution.
So we have grouped data.
I had to look that one up again.
So who can help Brooke out? We've got grouped data. So when we go to find the mean, what are we entering to find the mean of this group data and standard deviation and variance?
Don't you have to add the frequency up and divide them all by the amount of them?
Well, if we do that, how are we going to figure out if I just add the frequency and divide? How am I going to find out what the actual,
For P?
what was it?
Oh, I see what you mean.
This goes back to chapter 3. So we had 68 prices, right? Retail prices that fell into this category, but I don't know exactly where they fell. I don't know if they were all at 20,000 or if they were at 29,000. I have to have a midpoint to represent those 68 cars, right? Sold in 2019. So we have to find our midpoints first.
And to find the midpoint, you add the lowers of the So like for the midpoint of 10,019,999, you would add the 10,000 with the 20,000, then divide it by 2, so you get the midpoint of 15,000.
Okay. So this is now going to be our data value, right? And then,
Also consistent number changes for the lower of 10,000, so it's easier to go down that list.
okay, super, thanks, Joanne. So then, Joanne made a comment that it looks like our width is a consistent 10,000, beautiful. So what should our next midpoint be using the width and then the starting one of 15,000?
25,000.
25,000. And 35,000, 45,000, 55. Okay. And now we're here, right? So let's go ahead and go to StatCrunch, because this was something that I added in, and then there was a new video to watch, and so it's kind of a confusing part of the semester, which reminds me I get to go make some new videos for summer. So we're gonna put in our midpoints here and our frequencies here. So oops. There is a way in Desmos, but if y'all learn it this way, this is easier. I do like Desmos because once Desmos learns a pattern, it's just really quick. Okay. So once we have our midpoints and our frequency, and we're going to go to stat and calculators, and remember we're choosing that custom one at the bottom, and that does the weighted mean for us. Somebody write that down. Custom, I'm sorry, calculators, and then custom. And then your values are going to be in your midpoints, and your weights are going to be in your frequencies. And then you just hit compute. And voila. The best thing ever.
I did that completely wrong.
Me
Well,
too.
that's a good thing we talked about it. Brooke, did that help?
And for the variance, is the variance like the standard deviation squared, or is the standard deviation the variance squared? I can't remember.
I didn't see. Brooke, did that help on that one? Okay. And then can somebody help Brendan? Brendan, you've got a question. I'm gonna go back here. So we have the mean, we have the standard deviation, and then it says variance. So how do we go from the standard deviation to the variance?
I just put this in my notes and I don't remember where I left it.
Wait, is it the variance equals standard deviation squared, right? So you just square root it.
Yep.
Okay.
What?
You square it.
That's what I meant. That's what I meant. Square it.
He said it and then he said, and then he said, yeah, I'm like, no, no. Yeah, so you square it. So the standard deviation squared is the variance. So we just have the mean and the standard deviation, and then the variance is equal to the standard deviation squared. So you would use that to square it. And whenever it is, you don't have to worry about is it population or sample, because remember it's all estimated, right? Because we're using these midpoints. I just give you another answer on that page.
So for this problem, it is supposed to be a ridiculously large number, right?
For what?
The variance, right?
Yeah,
Okay,
because the standard deviation is a ridiculously large number.
yeah, it's gross to look at.
I have a question about the thing you accidentally said for the estimation on F. So like I was watching back one of the old videos and it did say we were, it was estimated based on the midpoint.
Mm-hmm. Right on.
Is it, I mean, is it wrong to say it's estimated based on frequency too? Because aren't we using that in the
Mm,
calculation of them?
But why are we referring it to estimated values? And the reason we're referring it to as estimated is because, like I mentioned earlier, is I don't know where those 68 cars fell. They could have all been at 20,000 or at 29,000, but we're letting 25,000 represent them as an estimation. So the reason we're saying estimated is because they are calculated based on midpoints.
Okay.
Great job. Good job, good job.
I'm curious on F and G then, like, I mean,
Okay, so we just talked about F, but
yeah,
did you hear me say that?
no, I wasn't really, I was actually doing the relative frequency.
Okay, so
I
let's
can
get,
watch it over.
I'll let Jesse answer the question about F because we just talked about it.
What's the question? I mean, like, just read the question again.
Yep, she just wondered.
I don't understand why we're using the midpoint.
Jesse didn't
Oh,
understand. why we're
wait,
using
I
the
know what it is. It's they are calculated based on midpoints.
You got it. And
I guess
then-
I guess I didn't really realize that we were talking about the same.
That's all right. So G, I wasn't trying to be rude. G says, if the researcher did not hear back from a luxury manufacturer about the MSRPs of their 2000, that should be 2019 models. This is an example of what?
Non-response bias, right? Because you didn't hear anything back.
Exactly.
So I did just figure out what I was, because I like to use my calculator still sometimes, and I was using the 1 bar stat in the calculator. But I never put the midpoint in. I just did it with the frequency list.
Well, there you go.
But I guess 30 should have been a red flag that that's not a not me.
Oh, that's okay. That's why we have review day.
Can we by chance go over page 675?
Mm. What questions do you have on there?
Well, all of them actually, but I mean, we can get just an idea because it's been a while and I did not do well in this in the first place anyways. So it's been a struggle. Even going back and looking at it, I still have a hard time wrapping my brain around it.
Okay, that's all right. So let's start with 14. I've got the answer there, but let's start with 14. So let's just not even look at that. Let's go back to our fundamentals of chapter 3 for just one moment. And I know you guys probably get, I'm like a mom that's reminiscing. And you guys are like, oh, she's told the story like 8,000 times. That's okay. You don't have to hear me tell it after tonight. And then you're going to miss me when I'm gone, right? Just like the song says. Okay. So we're going to, and I won't start singing. So we're going to go back to this 2 standard deviation rule. And we said that this is because this is outside the 5%, right? Which is 2.5% over here and 2.5% over here. And our confidence level would be 95%. They add to 100, right? And this is these are my Z scores. So let's go into StatCrunch for just a minute. Just gonna clear all this out. Okay, so I'm gonna go to stat and calculators, and I'm gonna go to normal. And because we're finding a critical value, I'm just gonna do between. And I'm gonna say I want 0.95. And look, it comes out to just about that 2, right? The plus and minus 2 that we just had in our paper. These critical values, Joanne, is what we established back in chapter 3, but at the time it was just a bunch of jumbo mumbo, right? And I totally agree. The ordering of which we teach the course is just the way they've always taught it, and most books come up with it, but I wish there was I would love to write a book someday on organizing this a little bit better. And you need to have a reason to know something, right? And I just told you that in chapter 3, and then it's like, oh yeah, we kept talking about it, but now we actually need to know is chapter 10 and 11. So this whole thing is, this is just our tolerance that we set up in chapter 3 is we said, okay, the typical thing is, the typical thing is we're considering something unusual, more outside these bounds of these 2 standard deviation, which is basically a 95% confidence level. So jump forward to our page here on 675, right? And we have an 82% confidence level, an 82. So I'm gonna go here and change my 0.95 to 0.82 and hit enter. And there is my critical T value or critical Z values for 82%, plus or minus 1.34. So if I want to be 82% confident, then my boundaries are, I have much more leeway, right? Which seems weird because it's like, well, wait, I can barely be outside of these.
So if we had one of these in the exam, would you want us to write out that formula or just like draw all the shade the area and put the Z?
Yep, I just want you to give me this right here and then show me that this is 1.34. Mm-hmm.
341
Was it 1.341?
It was 08, but it says 3 decimals, right?
Okay. I love when you guys catch me in the decimal rules. I'm a rule breaker, but you're right. It should be 1.341. So I told you at the beginning of the semester, after a little bit of my stat lab, you all would be rule followers on the decimal places.
I hated my stat lab.
Oh, which reminds me, everybody, make sure that you go and fill out the course survey. Say all the things that you'd like to say, good or bad. I will never, 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 ever know who said exactly what, even the ones that you type up. But we would love for those to have, comments for the dean to read, and I read those, and I don't get any of the comments until after the semester, and all your grades are in anyway, but it's good feedback for what things you liked, what you didn't like, what went well, especially with us going back in person. What things did you really like? A lot of people said they really like having the YouTube videos because they can go back and rewatch those, or the class sessions recorded. They can go back and watch those at any point in the semester. All those things. I would love to know all of those things.
You said you guys don't get to review them until the semester's over?
Yep.
Because I've been holding off on my chemistry one.
You're what?
I was holding off on my chemistry one until after the exam.
You will not see that until after your grade goes in, Jesse. Oh, geez. Okay. So let's look at this 15. It says the length of time it takes college students to find a parking spot follows a normal distribution with a mean of 2.5 minutes, give or take 0.65. So the give or take means that it's what? What is this 0.65?
The standard deviation.
Thank you very much. The standard deviation. Okay, so it says, assuming the scores follow a normal distribution, what is the probability that a single random parking search time is less than 1.4 minutes? So we're not talking about chapter 8 samples, we're talking about a single guy. So this is chapter 7. Okay, so we know that our mean is 2.5 minutes, right? And we want to find the probability of a single search time being less than 1.4. Okay. Well, 1.4 is to the left of 2.5. And I want to know, what is the probability of that happening? So this is not a critical Z value. It has a particular scenario, right? And my particular scenario is the mean is 2.5 and the standard deviation is 0.65. And we're going to leave that 0.65 because we're talking about a single parking time. We're not talking about chapter 8 where we're talking about a sample mean. Then we have to do this. Then in that case, we'd have to do the standard error. Okay. So let's go to StatCrunch. And then we should take a break.
Yeah, I don't even have myself.
Okay, so we're doing a standard. And so the mean here is, what did we just say? 2.5 minutes. The standard deviation is 0.65. And it's a less than, and we want to know what is the probability that it's less than 1.4 minutes. And I'm going to hit compute. And the likelihood of that happening is 0.045, so about 4.5% of the time that should happen. And this would be unusual, right? Because it's less than 5%. Oh my gosh, look at Emily's dog. How precious is that? Okay. Does that help, Joanne, on that one? I want to try B.
It does, but just real quick, where when we went to StatCrunch, where did you go to? You said what normal calculator? Okay, I see it now.
So calculators, normal.
Okay.
Yep, and then we have a standard. And we have to put in our situation, which is the 2.5 minutes for the mean and the 0.65 is the standard deviation. It was less than, and we wanted to know what is the probability of being less than 1.4, and we hit compute. So how about we take a quicker than a 10-second tidy, but we can, or longer than a 10-second tidy, but shorter than a 10-minute tidy. So I'll take a few minute breaks, stretch or whatever, and we'll be back. And let's do B together. So if you all want to look at B while we're on a break. It's our same scenario, but it says a student wants to take a class during the busiest time of day. To make sure they are on time, how long do they need to plan for it to take them to find a parking spot for the top 10% of times? So see where, I'll let you all graph. Where do you think the top 10% of times would be on the graph? Right here's our middle at 2.5. And we'll be back momentarily. Why did I do that? So we're working on number 29 with better data in. So T-stats and paired, we decided. And it did ask us to do after minus before. So that's why Trevor put it in like that. Sample 1 is after, sample 2 is before. And then he clicked on the save the differences. Excellent. And
larger than, right?
Yep, it was a greater than a word. Yep, because they said effective in increasing the athlete's strength. So we think it should be a positive difference. Excellent. So our test statistic is 1.81. Alpha, they said, was 0.05. And so step 4 is our picture, and that's a right tail because it's a greater than. And then step 5 is the p-value compared to alpha. And the p-value we have here is 0.0533. And our alpha is 0.05. So I'll let you all decide what we should do.
You want me to stop sharing it?
Sure. Thank you.
We will not reject H0 because the p-value is greater than alpha.
Okay. So our p-value is greater than alpha, so do not reject H0. And so there is not sufficient evidence to support the claim that the supplement increase the strength, increase the athlete's strength. Job. Oh, we got through a lot.
If it was less than 0.05, we would have the evidence.
Right, yep. So if it's less than alpha, we do reject and there is sufficient evidence. So step 5 and 6 is the same for all of our hypothesis testing. So if the p-value is less than alpha, then we do reject H0. And then we have our conclusion that we worked on in the chapter 10.1 lesson.
So every time you reject, there is sufficient evidence, and every time you don't reject,
There is not.
sufficient. Okay.
Yes, sir. Good question. And that can be referenced on in chapter 10. I'll find it for you. 10 is on page 225 in your course pack. Where we go through that. Rejecting is there is sufficient evidence, and do not reject is there is not. I take it as the not and the not go together. Do not reject and there is not. And then reject and there is. Does anybody have any aha moments tonight where you're like, oh, this something, whatever it is like, oh, that's kind of starting to make sense now? I hope. I guess I don't want to know otherwise. Thanks, Ashley. I appreciate the giggle.
You said you changed your mind. You're gonna let us use this practice exam on the exam, right?
No. You will not have time to sort through that.
There's a lot of pages.
Right. So the idea is that you work on it tonight. It's in layers, right? You never study, you never cram, you do things little by little by little. and then asking good questions, like tonight you're walking through things, tomorrow you do a little bit. It's like training for a marathon, right? You never actually do the marathon. If you've ever run a marathon or trained for a race, you never actually run the marathon. You work up to about 3/4 of the way to the marathon just to know that you mentally can get there and physically you've done enough. Then the day of the marathon, you obviously run the whole marathon, but it's yeah. And then the night before you rest.
I feel out of shape for statistics.
Pardon me?
I feel out of shape for statistics.
Oh, Emily, that's funny.
On page 669, where it talks about interpreting Q1,
Uh-huh.
we just say something like 25% of the data is equal or less than the 97.8.
Sounds pretty good to me.
You have to put in like,
So they were talking about body temperatures, right?
yeah,
Yeah, so you'd say 25% of the data or 25% of the adult males in 2019 had body temperatures less than 97.8.
that's
So,
like here. You got to put in like the temperature of the 130 adult males in 2019.
yeah, so I want you to talk about when it says context of the situation, I want you to mention the temperatures in the 2019 and all that. Correcto. But you had the gist of it being the 25% less than that value.
Is it less than or equal to, or just less than?
I would say less than or equal to. Usually 25% is less than that value, but it could be one of the data points falls right there at that value. Mhm.
On page 679, on number 22, C, it says state the confidence interval without using your calculator.
Mhm.
And I'm not understanding what it's actually wanting from me.
So that's a good question, Bridget. So if I said I did a survey and 95% of my class was super happy with it, give or take 2 percentage points, what would you maybe say the ranges of people that were happy with my class?
Okay, I get it. That's actually quite easy now that you said that. So it'd be, yeah, 92 to 98%, right?
Right, so you
Okay.
subtracted 2 and you added 2, right?
All right. I'm overthinking things.
That's right. Or whatever I can't remember my numbers I threw out there, but yeah, so if I said 95% of the class, give or take 2%, so I'd be subtracting 2, so that's 93%, and I added 2, so that's 97%, right? So here on this one, it says 68% of those interviewed said yes or probably yes. And then they said the margin of error is 3 percentage points. Yeah. I know when we don't have like the data, everybody starts to get stressed out. And it's like, we talk like this all the time, right? Out in the real world, we just forget about it.
So do we put that down as 65%, 71%, or 0.65 and then 0.71?
Either way, either decimal, or if you say 65, I like the symbol, the percentage symbol next to it. Yeah, good question, Trevor. Trevor just gave everybody the answer to C.
Everyone knew it once they heard the example.
It's actually, that's not a silly question, Bridget, or laughing, Trevor. A lot of students miss that. If I were to put that on the final or the midterm, a lot of students get tripped up, and it's like, it's just an everyday conversation, right? But we get so caught up in there must be something big I have to do with Stack Crunch, you know what I mean? So nope, it's just subtracting 3, adding 3. Sometimes things really are as obvious as what they seem.
Those seem to be the ones that I have the most trouble with on this exam here.
Oh. Then you'll be like, oh, I totally got this when it comes to the final.
So going on to D on that one,
Uh-huh.
it says the majority, so that means more than 50%, correct?
Mm-hmm.
And so we would support the conclusion because both of those in the interval are over 50%.
Oh, that's a good question. Yep. So the entire interval is bigger than 50%, so I would agree. We would support that.
That's all we would put. Yes, we support. We don't have to explain why we support.
Yeah, Trevor just explained it.
I know, but would you want us to write that down? Or?
Yep. Yep. I want you to tell me like what happened with the interval. So if there's no difference, zeros in the interval. In this case, we do support because the entire interval is bigger than that majority of 50%. Mhm. Yes, sir. Anytime you see explain in big bold letters, expect that there's extra points there. And I'm not an English teacher, so it doesn't have to usually be a very long sentence, right? A lot of times it's like point to something or show me the inequality or use the interval, but yeah.
I know we talked a lot in class about the zero being in the interval. What was the significance of that?
The zero in the interval. Yeah, anybody want to throw their
I think
idea?
it was in relation to like the lower and upper.
If we're comparing, if we're saying, is there a difference between two samples? If there were no difference and I subtracted their means, I would assume that the difference between them would be zero, right? If there were no difference between the two groups. And so if I do a confidence interval and zero is inside that interval, it's very likely that I'm predicting that there is no difference between the two groups because zero is inside that interval. Now, if zero is not inside the interval, then I'm thinking that there's sufficient evidence to say that there is some kind of a difference between the two groups. Jesse's got all the deep thinking questions tonight. The day game. So you guys can hang out and keep working. It's after 8. By no means anybody has to stand here, but I'm happy to keep answering questions.
Is there a way we can go on page 678 and number 20, just to, even if it's just doing E, just to make sure that I'm understanding and not overthinking?
Okay, so what are you thinking on 20E?
So like I'm looking at like the first one, it says whose results are specifically significant at a, and that's where I'm kind of like, okay, do I need to do a formula? Because I'm thinking of everything we've learned since the chapter. So I'm thinking I'm going too far into it and it's not that much.
There's only one way that we decide if something is significant, right? Statistically significant. Can somebody tell us what is the one thing that we do? Every single time. It's on the screen. How do we decide if something is statistically significant every single time?
when the p-value is less than the alpha.
Okay. So rejecting H0 is synonymous with statistically significant.
Okay, so that is for any kind of these questions like this. This is what I need to be thinking about.
Yes, anytime, whenever we talk about statistical significance, we're always looking at, is the p-value less than alpha? It's always set up like this. Yep. We only use the words reject H0 when we're specifically talking about a hypothesis test, but statistically significant is if the p-value is less than alpha. So which of these, Jasmine at 0.04 or Dre at 0.056, neither of them, Jasmine, Dre, or both of them would be significant, statistically significant at 0.1.
Well, they're both less.
Okay. So
Sorry, I was talking to myself. The p-value is less than the alpha, which is what we need to go on. So would it be both researchers? It'd either be neither or both.
well, you tell me, Joanne, you just answered your own question. I'm trying to build some confidence in you. You
I
know the
know.
answer.
I'm thinking it's both.
Okay, and why is it both? You just told me. Why is it both?
Because the p-value is less than alpha.
They're both less than 0.1.
Okay, so that does help me then going forward to the next ones also, because then on the next one for F, if it's the significance is 0.05, so Dre would be the one that is higher, so it would be Jasmine for this one for F. Is that correct?
Okay. No, you're telling me if it's correct.
Okay. So it's Jasmine.
Okay.
And then let's see, so and then for the last one, I would say neither,
Okay, why is that?
because their p-values are, both of them are higher than the 0.01. Okay, that was easier than I thought it was.
I'll just drive home that rule real quick. So if the p-value is less than the alpha, it's significant.
I'm writing it down here. Yep. If the p-value is less than alpha, it is statistically significant.
What's the difference between E and G?
That's a good question. Well, one is 0.1 and one is 0.01.
Oh, okay. That's I kept reading them back and forth, like, why do they say the same exact thing? Details.
Can we kind of just go over the errors, like type 1 error and type 2 error? It's on page 681, but just even if I can get a better breakdown of how I can decipher which one is which.
It's on what page did you say?
81.
There's a question on 681.
Yeah, it's question D, but I just didn't know if anybody has any like easier way to like remember which error it is going to be.
Okay, so you can reference page 227 in your course pack. So type 1 is always, you can only end up having a type 1 error if you rejected H0. And a lot of times we do this, we'll have you walk through a scenario and then we're like, oh, if you really did this up here, what type of error did you commit, right? And so you can only commit a type 1 if you rejected H0 and then H0 actually happened to be true.
Is this that thing that where you do like the boxes?
You could, yeah, you could do a box if you wanted. Yep.
Okay.
Same thing. Similar thinking on page 226. Yep. And then you can only commit a type 2 error if you did not reject H0, but then you found out H0 was really false.
And then on 25, can you reference like what part of like what chapter that is so I can go back and redo that also for the appropriate computing?
Which one again, hon?
It's number 25. I'm thinking that's probably 25A through C is probably the same chapters area. It's on page 681.
Yep. So this one says, write the formula that is appropriate for computing the minimum random sample size. So that's either going to be page 266, is it? Which is chapter 9 in the yellow pages. Or page 269, which is chapter 11. And then you're going to go through the questions. Is it proportions or means? You already know that they want sample size, so that's already narrowed that down, right? So you need to know, is it proportions or means? And then is it one sample or two sample? Because that's chapter 9 or chapter 11. Mhm.
I think we already went over page 675, but can you bring that back up really? I have a quick question on number 15A. Oh, actually, I just answered my question. Never mind. I was trying to find out where you came up with the 2.5, but it's on the very beginning of that. So.
Okay, we got that. For sure, then chapters 9 through 11, you guys, I think we went through every single problem pretty much. Yeah.
So what, like what portion of the exam is gonna be 9 through 11?
Oh, I'd say the majority, so at least over half of it's gonna be 7 through 11. But there might be like one big kind of overarching question, kind of like on the front page. I'm not saying there's one just like this, I'm just saying there could be like a big, I might ask a couple of big overarching questions about the earlier stuff, just to make sure that you've got like the big takeaways from that. But the majority is the 7 through 11. Yeah.
On page 672, it's talking about the probabilities. And in this chapter, I know I kind of struggled when we were going through a lot of it. Question 8, letter C, where it says, what is the probability that a randomly selected bead is not green?
Yeah.
Those ones I always kind of didn't get right.
Okay, so we're selecting one bead. So what is the probability that a randomly selected bead is not green? So what ones would be considered not green?
All of the others.
Okay, so we've got a couple of options how we could find that probability.
Is the probability that it is green 1 in 7? Or
I'm sorry, what'd you say?
is the probability that it would be green 1 in 7?
1, 7.
1 out of 7? Or
Nope,
do I still gotta look at
because the
these?
probabilities are already up here, right? Their likelihoods. So it looks like 20 out of the 25 beads, 28% of them are red. That's how this reads. They already gave us the probability. They're not all equally likely to be drawn.
Bless you.
Thank you. Do you see that, Jesse? They didn't say,
Yeah, I see. Okay.
okay, yeah, so they didn't say,
There's an equal chance of equal
Right.
likely, like with rolling the dice.
right, yeah.
They all, the probability all adds up
Not
to
a fair
1.
game.
Right. These are not. So what, Emily, what'd you say about the probabilities?
They all add up to 1.
Okay, so that's good to know. They all add up to 1. So the likelihood of all of them should be a total of 1. So that's good that that did happen. So how would we find out the probability? This is, does anyone remember what the C means here?
The complement.
Okay, so that means I'm talking about everything but a green, right?
Mm-hmm.
So what's one way I can find out what is the probability of not getting a green if I were to reach in and grab a bead?
Can you do 1 minus 0.16?
Okay, so I could just say, because like Bridget said, they all, except for the green, satisfy this question, right? So we could just say, well, then let's just take 1, like Emily mentioned, they add up to 1 and just say, let's just subtract the green because that's the one we don't want. So the probability of a not green should just be 0.84.
Should it be a percent?
You can leave it 0.84. You could, if you wrote it as 84%, that's fine by me as well.
So the one above that, when it says the probability that a randomly selected bead is red or green, would we just add those two amounts together then?
You mean brown or red?
Oh yeah,
Yeah.
that's what.
Mhm. Yeah, so the probability of brown or red. You're right, we can add those together because you can't be brown and red at the same time, right? So that means that we can just add them. So that would be the brown is the 0.08 plus the 0.28, so 0.36. And what about A? The variable bead color is,
Qualitative.
yeah, qualitative. And what about D?
Wouldn't you multiply probability of white by itself?
Okay, so we're drawing two beads, so this would be the independence situation, right? So the probability of white times the probability of white, because we want white on both beads. So independence means that we can multiply their probabilities together. So yes, Ashley, we can just do white, which is be 0.2 squared, which comes out to be 0.04. Any other questions?
Can we kind of talk through on page 681, and I don't know if I missed it and you guys already talked about it. Number 24A.
I'm sorry, what?
It's on page 681 and 24A, and you might have already, and I might have missed part of it, the conversation about it, but I just was wondering, like, is this one of those ones that would have steps to find out which one we want?
So. But we're just looking at what this is what came out of the stat crunch, right? So what does the hypothesis tell us? In words, essentially.
Sorry, my phone was being weird. Let's see. The error, okay, so so 675. So it looks like the sample mean is actually higher than what that they were saying, because they were saying it was 67.5, and the sample mean is showing that they found that it was 69.7832.
Okay, so that is true. Your statement is true, but it says which claim. So what is the claim? So the claim means we're not looking at the evidence. It's just what is their opening statement, right? As the attorney. And so what is the claim? So the claim is this right here. And you're right. The claim is that it's bigger than 67.5, but we're not looking at the evidence yet.
So well, I noticed the word increased up in the 2024. So she is thinking it's increased. So,
and that is right here. That's what I'm saying. I'm pointing to the hypothesis statement. So you're right. It is greater than. So the researchers believe that the average of males' heights are higher than 67.5. This is their claim right here. The HA or the H1 is what they're claiming. That's different from the historical evidence.
okay, so I'm overthinking. I'm going too far, and it's just a simple question, not the whole breakdown of everything. Thank you.
Yeah, sure. No worries. Yeah, we're just basically asking you to interpret what does this mean right here. I gave you what it is, and what does it mean in like our regular everyday life. Mhm. Any other?
Can we look at page 677 and it's C, and can you kind of just show me if the basics for, I believe this goes into StatCrunch and it goes to calculate, I think it is, but can you verify that I'm correct in that?
$677. This one?
Yeah, sorry, my phone again is being weird.
Okay.
Okay, yeah, so it was C, which I'm actually right for one. So I don't, okay, so let me look at that, something, okay. So you read it percentage though, instead of just leaving it at the,
Oh, you can write it, you could leave it as 0.6046. Yeah.
okay, I just wanted to make sure because I didn't have that, so.
Can I see A one more time? I think that was like the first one that I missed.
A,
Yeah.
I didn't go over them. When the question was brought up, they said B, C, and D. So what would the three?
Is that like where it's a random,
Random sample is the first one.
uh, not the population, but the samples greater than or less than 0.5% of the population?
Yep, so the first one was the random, the second one was, what is our sample size?
Sample size is 35.
So we want to prove that 35 is less than 0.05 of the population, which would be all humans.
Like 6 billion.
So that's pretty much enough, right? We can prove that 35 is less than 5% of all humans.
In that question, that's all it wants is just the 1 through 3, nothing more.
Right, yeah. And those are all on the yellow sheet that we went through. The central limit theorem and then the shape, center, and spread.
So I'm on 11G and it's asking, it's a probability question and it's like good or earned a bachelor's degree. Is that, do you add the probabilities together?
So what would it look like to be good? So good would be all of these people, right?
Hmm.
And then bachelor's degree would be what?
The 73.
Would be all of these people.
Hmm.
So are they mutually exclusive? Can you be
No.
both?
Yeah.
Right, so what do you have to do when you can be both?
It's like subtract that 24.
Mm-hmm.
Uh,
Yeah, so go back to chapter 5
thank you.
on the or. Yep, chapter 5. So if those are not disjoint events because you can be both, so that rule is on page 148. Brooke. Need to. So we have the overlap, right? So the good. Plus the bachelor minus the overlap. And the other ones.
If, can we go back to that page you were just on the page 673, and can I just kind of tell you what I got for like E, and if you can tell me if I was on the right path?
Mhm.
So for E, I just put 39 over 160. I didn't break it down. I just kind of did it very basic. Did I do that correct? Oh,
But
it's
I want it in 3 decimal places, but yeah.
That's
I don't-
really right.
Yeah, does anybody want to agree with that?
It's wrong because I did it. I just said it in here, give 3 decimal places. So I obviously did not do it right.
But I mean, you would use what you came up with to get to 3 decimal places, right?
Yes, yes. I just was not reading enough into it. So I'm glad I asked that question because I would have had that wrong.
That's right. So yeah, 30. So what is the 160? Is that your total right here in the corner?
Yes, I have 160 in the corner as my total. And then I just took the, I selected a random manager that is a rated good. And then I went to the good across, which is 39.
Mhm.
And then I put that over the 160. And then I just gotta divide it through to get it the percentage.
Okay. Mhm. You got this. You guys are gonna be great. Is she like, I want dad? Is that why she comes in? Is she like, oh?
Who's the baby?
Mhm.
No, my girlfriend had to run out real quick.
Oh, it's so precious. Gosh, so precious. Okay, any other questions from anyone?
I have a question on 16B. I cannot figure it out for some reason.
What's your question? What,
So for the center and spread,
the shape, center, and spread?
mhm,
So are we talking about means or proportions?
proportions.
Okay. So the center should just be the center, the typical proportion that they gave us, right? So chapter 8. So what is the typical proportion that they gave us in the problem? So we're going to be looking at the typical proportion, the p-hat, and then the standard error is going to be our spread. So the p-hat is what they gave us, the 89%.
Okay.
And then the standard error is the p-hat 1 minus p-hat divided by n, which was 120. Mhm.
Oh, okay.
Mhm. Let's see.
Thank you.
Of course. And then you'll use that scenario to answer page or problem C. And stat crunch. So. Any other questions? I need to get some rest. I'll
You're free.
huh?
Said you're free.
Yeah, I guess you guys can all stay on together and I'll just turn it off later.
Hey. I'm in class, remember? Yeah. Yeah. Wow.
Okay, I do kind
That
of
one
have
of
one
your-
question
Are those all your
Um,
news?
because it doesn't make much sense. Sorry.
That's
It's
right.
3F on
Um,
page 669 or 669.
uh-huh.
It asks to interpret the mean and standard deviation. And I know it's like we expect males in 2019 to be 98 or to have 98.25 degrees of a body temp, give or take 0.73. Is that right?
Yeah.
Is that right? Okay. It just didn't sound right. So
Yep. It's perfect. Perfecto. Well, I think we covered, pretty much all of that whole thing.
Good head start on getting this finished tonight.
Yeah. You got this. Okay.
And a lot of it actually helped me with my notes I'm going to be using too, like different things, how they kind of pop out like, oh, that's how you do this. It's helpful with my notes.
Mhm. Okay, I will get this uploaded.
Thank you for your extra time going through this.
Oh, you're very welcome.
Yes.
I'll see you all on Wednesday or
Yes,
Thursday.
thank you.
Hope you feel better soon, Sadie.
Thank you.